I'm James Nicodemus, and I am going to be demonstrating how we separate salt from pepper. So my first thought here is I took 10 cc's, measured 10 cc's of salt and 10 cc's of pepper. I want to see how heavy these are. So we have the same amounts. Now we're going to weigh these. I'm going to start with salt. And salt, 10 cc's of salt weighs 14 grams. 10 cc's of pepper weighs 8 grams. Now my second thought here is we have some salt and some pepper, and I want to see how buoyant or how heavy it is. So I'm going to first start by pouring some salt into this water. We see that it looks like it just sinks straight to the bottom. Now I'm going to pour in some of the pepper and we'll see what it does. And that looks like it floats on top. They're about the same size grains. The pepper is probably a little bit finer than the salt. But at least we know that so far it appears that the salt is a little bit heavier than the pepper.
So as we measured the pepper, we found that it was certainly a little bit lighter, almost half as light as the salt was, and then it also floated. We know that salt is made up of both sodium and chloride ions, and that pepper is made from organic plant material, so organic materials like hydrogen carbons and oxygens. So now we're going to go ahead and see about separating the two.
Taking the salt and the pepper and mix these two together here. And we're going to put it on this plate here, mix these up real good. You can see that there's a good variety if you want to focus in on that a little bit there. You have a good amount of salt and a good amount of pepper all mixed together. Pretty hard to separate them unless you're going to do it one grain at a time. Now I'm going to take this balloon and we're going to rub this and get some good static electricity on there. So we know that if we get some electricity, static electricity on here, will have a negative charge. Then we'll hover it over this salt and pepper mixture and see if there's a charge or if there's an attraction here. So I'm going to come over here and get some good and if you doubt the static electricity, we can see this hair quite sticking up. Now I'm going to come over here with the nice, if you feel the static on there, we'll just kind of hover this and we can hear some of the material jumping up onto the balloon. Now we can look on there. Looks like we have a pretty significant amount of pepper on there. There's a little bit of salt, but most of that looks like we've got a good amount of pepper on there. Looks like mostly pepper. If we do this for quite a while here, I imagine we get all the pepper off there. Like I said, there's a teeny bit of salt there, but the vast majority of that is pepper on this.
So we can see that the balloon has a bit of a negative charge, creating a static electricity. Then we have our particles on the plate, and we see that the pepper particles jumped up onto the balloon. A little bit of the salt. What that is telling us there, at least two things: that we know that both the pepper is a little bit lighter than the salt, so it's easier to overcome the gravity and jump onto the balloon. And then it appears that the pepper has a bit of a positive charge and is attracted to the negatively charged balloon, and then it begins to pull those off. So in conclusion, it appears that we have pepper appears to be lighter than salt and overcomes the forces of gravity more easier than salt. A pepper appears to have a slight positive charge and is attracted to the balloon, which has a negative static electricity charge. So the pepper sticks to the balloon, and the salt mostly does not. So thank you very much for watching this presentation.